Hello everyone, welcome to our new video. Today we're going to talk about reciprocal functions. So basically we're going to study what is exactly a reciprocal function. Also, since we're familiar with domain and range, we're going to find out how we find reciprocal function domain and range. And also we're going to talk something very important about reciprocal function, which is asymptotes. So probably you have seen that word at your school, your homeworks, or your quizzes. So let's start. Basically, we know that we define a function by fx or function of x. I have previously taught this in the previous videos of my channel. The way that we define the reciprocal function is that the function is equal to 1 over another function like gx. So basically this one here is another function, or let's say this expression that could be anything involving x. For example, this one could be something like, let's say gx is only a simple function like x, or gx is x plus 1. So in this case our function of x is equal to 1 over x, and for this one the function of x is equal to 1 over x plus 1. So it's very simple. As you can see, this one gx could be any number right here, sorry, any expression or function. For the first example we said that, let's say just gx is x. For the second one, let's say gx is x plus 1, and as you can see, we just replace that with gx here and we have the functions right there. Alright, it's very simple, right? The way that we sketch the function is also very simple. So if this is our Cartesian plane and this is our x, this is our y, the way that we, let's use a different color actually, maybe this one. The way that we sketch the function is like this. So the function basically has two different parts, and I'm just sketching the first one. So this is fx equal to 1 over x, the simplest reciprocal function. So as you can see, this function has two different parts, right? This is the first part, this is the second part. The main point about this function is that, as you can see, this function goes to infinity, and here also infinity here, but this line never touches the x and y axis. It's the same story for the second part. So this goes to negative infinity, this goes to negative infinity, but this line never touches the x axis. And that gives us a very important information about the domain and range. The domain of this function, d, is, as you can see, all the real numbers, or XCR, except, well, 0. Because, maybe use this, because the lines, the first and the second part of the function never touches the x-axis, or x is equal to 0. So the domain is basically all the real numbers except 0. The range is also all the y values except 0. And we call these lines asymptotes. So this one and this one are our vertical and horizontal asymptotes. Basically, these are the lines that our function never touches. So vertical asymptote, which is x is equal to 0, and our horizontal asymptote, which is y is equal to 0. So this is a very simple question, a very simple explanation of the reciprocal function, and it was a very easy one, right? It was just 1 over x, and we can see how we sketch the function, how we find domain, range, vertical and horizontal asymptote. Now, please consider this specific frame. I'm going to remove everything and then give you guys another cool question. Imagine that this time we have a different one. So this time our function looks like this: 1 over x negative 2 plus 1. And we would like to sketch the function, find the domain, range, and the asymptotes of the function. Okay. Since there is a negative value right here, the function shifts to the right by this much unit, 2 unit. So if we have x negative something, the function goes to the right by basically that many units, 2 in this case. If, for example, it was x plus 2, the function would have shifted to the left by 2 units. But now the function shifts to the right by 2 units. So instead of 0, the starting point is 2. Since we have another plus 1 outside this part, then the function shifts up by another 1 unit. So again, if this is positive right here, if it's positive, the function shifts up. If it's negative, it shifts down by that many units. Here, if it's negative, it shifts to the right. If it's positive, it shifts to the left by, well, this many units. Now, we have the starting point, right? The starting point is right here. 2 points shift to the right and 1 shifts up. Then this is the way we sketch the new one. Actually, this should be here because they shouldn't touch these lines. So in this example, our domain is again XER, or all the real values except, well, this cannot be 0. X negative 2 cannot be 0. We know that if x is 2, this is 0, so it's XER negative 2. If you take a look at the graph, it's also obvious because the function never touches x equal to 2. Your range is YER, or all the y values negative 1. So again, just take a look at the graph. It's pretty simple. It never touches y is equal to 1. If you don't want to use the graph to find the range, just take a look at this number. Basically, your range is all the y values except that number. We have 2 different asymptotes. This is the vertical one, and this is the horizontal asymptote. So your vertical asymptote is x is equal to 2, and the horizontal one is y is equal to 1. Pretty simple. So now we're familiar with reciprocal function. We sketched 2 different functions now, and we also know how to find out the main, range, and different asymptotes of this function. Please let me know in the comments what other subject you want me to teach you guys, and if you find it useful, please don't forget to like and subscribe, and also let me know in the comments if it's not clear, or if you need more help with this, and I'll try to solve more questions about reciprocal functions. Thank you guys. Have a great day. Bye bye.